Adding and subtracting, also known as superpositioning of graphs. They use that word in physics, don't they? Superpositioning. So basically adding and subtracting the y values. So x plus 1 on x. Well, easiest way is to draw the two graphs. There's y equals x. There's y equals 1 on x. And so we just physically add the y values together. Now, any problems with the domain will remain. You know, x can't equal 0 in the hyperbola, so when I add it to something, it can't magically become 0. It's still going to have an asymptote there. So look at these key points. 0, which in this case doesn't exist. So we're not going to have an issue there. Stationary points, they're important. Well, we haven't got any stationary points on this one. Points of intersection, though, of course, are another good one to plot, because I know I'm going to just have twice that value when I add them together. But if you think about it logically, this hyperbola is getting closer and closer to the x-axis. In other words, closer and closer to 0. So we're adding to this line of x, so we must end up getting closer and closer to the line y equals x, because we're adding smaller and smaller amounts. So let's plot some points. There we go. And we can pick as many as you like until you get a feel for what the graph's doing. And voila, we get y equals x plus 1 on x. Things to keep in mind. As I was just saying, discontinuities, they're going to remain. The x value can't magically jump into the domain of the new function. So x plus 1 on x we just drew, but 1 minus 1 on x. If I was going to add these together though, here's the interesting bit. See, if I add them together, I get y equals x plus 1. And the mistake would be to draw y equals x plus 1, but x can't equal 0. So it's the difference between drawing the line y equals x plus 1 and drawing function x plus g of x. So yes, it looks like x plus 1, but we would have a point discontinuity there at 0, because we cannot substitute that into function x plus g of x, which they've asked us to draw. X-intercepts. So when you're looking at the graph, whenever the amount above the axis is the same as the amount below the axis, well, if you add them together, they must cancel out and you'll get the x-intercept. Symmetry. You're going to retain some sort of symmetry. So remember, an odd function plus an odd function, you'll still be an odd function. An even function plus an even function will still be an even function. Odd plus even, no, you're going to lose your symmetry there. These sort of absolute value ones, remember you got two absolute values added together? I think it's easy just to look at the critical points and just consider what's happening at the critical points. So the critical point's -3. So if I was to pick a number smaller than -3, well, the absolute value of x plus 3 will be negative x plus 3. Remember the formal definition of absolute value. It's equal to x for when it's greater than 0, but it's equal to negative x when it's less than. So in this case, it's less than -3, so I'll get negative x plus 3. If I was to substitute a number into the second one, I'm actually going to end up with a positive number. So that'll be plus 1 minus x. Add those together. All right, so we know we're going to draw the line y equals minus 2x minus 2 on the left-hand side of -3. The next critical point is over there at 1. So what happens in between -3 and 1? Well, 0 is the easiest to substitute in for this one, so we shouldn't have a problem here. X plus 3, well 0 plus 3 is positive, so it'll stay x plus 3. 1 minus 0, that's positive, so that'll stay as 1 minus x. And we just end up with the constant line of 4. And let's see what happens on the right-hand side there of 1. Sub 1 in, x plus 3, well that's positive. So that'll stay as x plus 3. 1 minus, well, that'll end up negative if I pick a number bigger than 1. So that'll become minus 1 minus x. And we end up with the line 2x plus 2. So we have this lovely graph which starts with minus 2x minus 2, which stops there at x equals -3. It then goes horizontal until it gets to x equals 1 and comes back up to 2x plus 2. Now, if you have to draw two graphs subtracted, personally, I'll just draw negative gx and still just add like normal. I just find that easier. So if I had to do x minus sine x, so there's y equals x, the red line. There's y equals minus sine x, and now I'm just going to add those two curves together. Well, key points. The intercepts, so if I add 0, I must remain on the other curve. So there it's 0, I remain on the other curve. There it's 0, remain on the other curve. The turning points are always interesting. Unfortunately, because of the size of mine, I can only really use the x value of 2 of the turning points there. Draw it in, just draw it in rough. But notice this, it does end up with like a curve winding along y equals x, but it's not a perfect sine curve along there because it's weighted, I guess, towards one side. 7 questions. We'll do that like that. Well, some of us will.